Hello my dear students. So today we are going to solve this question. This question seems to be a part of moment of the fourth chapter. So let's solve this question. So figure 2.1 shows mobile bird sculpture that has been created by an artist. So this is the bird sculpture that has been created by an artist. So here M is the center of mass of the bird sculpture, including its tail, but not including counterweight that will be added later on. So here they will add some counterweight. So that has not been added yet. Okay. So they have not added here counterweight. The mass of the bird and tail is 1.5 kg. So whole mass is how much? 1.5 kg. So here this whole mass of this bird is 1.5 kg. Okay. The sculpture is placed on the pivot. So this is the pivot where it has been placed. So when now here when counterweight will be added, so it will come into equilibrium position. So that this type of question it is there. The artist adds counterweight at the end E of the tail so that bird remains stationary in the position shown. So later on here he will add like this counterweight. Calculate the mass of the counterweight. So we want to find the mass of the counterweight which has not been added yet. So how we can calculate here? So we will use moment formula. So as you can see here, we know mass of this bird, so 1.5, and this perpendicular distance here is 12 centimeter. So here we can write here 1.5 into 12, okay, centimeter. Okay, so is equals to, now here counterweight, let's assume that counterweight must be x. So x into perpendicular distance is 30. So 30. So let's solve this. So x equals to 1.5 into 12 upon 30. So which will come to 0.6 kg. So we got this. Calculate the mass of the counterweight. So mass of the counterweight is how much we got? 0.6 kgs, kilograms. So here we got it. Now 0.6 kg we got. Now we will do the second part of the question. So second part of the question says that the center of mass of the sculpture with the counterweight is at the pivot. Center of mass of the sculpture with counterweight is at the pivot. So this is the pivot and center of mass. So the counterweight and this mass of the whole sculpture is at the pivot, this position. Calculate the upward force acting at the pivot. So upward force we want to find out how much upward force is acting on this area, pivot. So how we can see, we can find out upward force equals to downward force. So here this two downward force, if we are able to find out, so when we will add, it will be equal to this upward force. So let's this upward force. So this downward force when we will add, suppose this is A, this is B. So A plus B and this is C. A plus B equals to C. So in this way we can find out. So let's do this. So calculate the upward force. So first we will find the upward force of this area. This area here, different areas are there. So we can find the upward force of this area first. This left side area, left hand side. So left hand side we can see mass, how much mass is there. So mass of the left hand side is here in the question 1.5 kg. So mass is 1.5 kg. So you know the formula for force equals to ma, but here it is acting like gravity is there, so we can use mg instead of acceleration. It is acceleration due to gravity. So for this side, left hand side, so mass is how much? So mass, as you can see in the question, it is 1.5 kg. So 1.5 acceleration due to gravity, instead of 9.8 meters per second square, we will take 10 meters per second square. So let's take 10 because it is not mentioned, so we can take 10. So here we got here as 15. Now for our this side, right hand side, we want to find out this area, right hand side. So right hand side equals to same, F equals to mg. So mass, here we got mass of the counterweight that will be added. So the mass of the counterweight we got here, we have solved here. So that is 0.6 kg. So here it is 0.6 kg, 0.6 kilograms, okay. So 0.6 kilograms. So let's substitute here. Force equals to 0.6, and acceleration due to gravity is how much? 10 we will take here. So it will become 6 Newton. Here it will be 15 Newton. So now we have to add both, because upward force acting, we want to find out what? Upward force. So upward force is equals to this plus this, both the downward forces. So this is the formula for moment. So here upward force equals to downward force. So 15 plus 6, which will come to 15 plus 6 equals to 21 Newton. So the answer for this is upward force acting on pivot is 21 Newton. So this part of the question we have done. Now let's do the third part of the question. So the third part of the question C, this is actually theory part. So let's do this. The sculpture is rotated clockwise to position shown in figure 2.2. It is held still, then carefully released. So what they was state whether the sculpture will stay in that position, rotate further, or clockwise, or rotate anti-clockwise. Yeah, three either this, it could it will stay in position, or it will rotate further clockwise, or it will rotate anti-clockwise. So out of 3 options, we have to find out what will happen if we have added the counterweight. So as you know, counterweight will bring it into equilibrium position. Okay, so when it will bring it in the equilibrium position, so it will stay at that position only. It will be stationary. It will not move at all. So you can write here as it will stay in the same position. The same position as it is in equilibrium. So here you must have understood this part. Now second part of the question, let's see. Explain the answer to part 1. So why it will stay in the equilibrium? We have written here equilibrium, na? Equilibrium. So why it will stay in equilibrium? Because as you know, clockwise moment is equals to anti-clockwise moment. Because clock moment will be equal to anti-wise moment. So because of this, there will be no resultant moment that will act. So there will be no resultant moment that is acting. And center of mass is at pivot point itself. The center of mass will move at the pivot point because it has been balanced. So center of mass will move, both the center of mass will move here. The center of mass will from this side and this side when counterweight is added, so it will move here. So center of mass will be at the pivot point. So center of mass will be at this point also. You need to write T of mass will come at the pivot point. So in this way we have solved this question. Don't forget to subscribe my channel. Thanks for watching. Have a nice day.